Hi there. Today we're going to start, just take a little taste of what trigonometry is. I always tell my trig students that it's just kind of geometry on steroids. So let's take a peek at what trigonometry is all about. All right, so it's about, trigonometry comes from the word triangle, and metrometry is like the measure of triangles. So when we look at the ratio, because we just came out of doing ratios, so look at the ratio of the sides in this right triangle. Now this, what we're doing today is all about right triangles, so we will assume that's a right angle right there. And so we're going to compare then, and this is hard in class, I'm able to enlarge that little triangle, but what we do is we compare this leg to maybe this leg in this little triangle, versus if I were to enlarge it and just grab it on the corner, and it would turn into like this triangle if I had done this. Let's see if I can make this work. Well, I'll just draw a bigger one of it. But if I just drag it and grab it bigger, the angles all stay the same. That would stay the same as that. This one would stay the same as this. And these right angles would stay right angles. So I know that my two triangles are going to be similar by angle-angle similarity, which means all their sides have that same ratio. Now in trigonometry, we compare certain sides of these similar triangles. So we're going to look at, like if this angle here, I'm just going to make it up, let's say it's a 30-degree angle, and so is this one. That's a 30-degree angle. With a 30-degree angle in this triangle, and then of course that'd be a 90, and this would end up having to be a 60 up here. So with that shape of a triangle, what is the ratio of, let's say, this side here, this leg, to this leg? What is that comparison? Well, it would turn out, remember, that since the triangles are proportional, that ratio would stay the same right here. Whatever this short leg to this long leg would be the same as this short leg to this long leg. And if I made it even bigger, it would keep that same ratio as long as my 30-degree angle stayed here. All right, well, and then I specifically said these two sides. Well, I could easily check this side compared to this side, and it would have the same ratio of this one to this one. Okay, that actually has a name. We have a name for all the different ways that you can grab two sides and look at the ratio. Okay, so let's start with this one here. If I know this angle here is, I'm just going to call it angle B, so whatever this angle is, if I'm trying to compare this leg to this leg, that ratio, it won't matter how big I enlarge this triangle, that ratio of this, we call it the opposite because it's opposite of the angle, that opposite side and this hypotenuse, because that's across from our right angle, the ratio of the opposite to the hypotenuse will stay the same in every triangle that has this same size angle. Okay, so if it has the same ratio always, okay, we give it a name. The sine, we call it the sine when we look at the ratio of the opposite leg to the hypotenuse. Anytime you look at that ratio, that's called sine. If you look at the ratio of what we call the adjacent, because it's right next to our angle here, adjacent leg to the hypotenuse, we call that cosine. And if we're looking at, and this is the one I had done earlier, if I'm looking at the two legs, the opposite and the adjacent side, again, compared to this angle, we call that tangent. Sine, cosine, and tangent. And then we have this little acronym here that we use. It's called SOHCAHTOA. SOHCAHTOA. And it's just an acronym to help you remember what name goes with which sides. So the sine, so that's S for sine, is always your opposite over your hypotenuse. Cosine is adjacent over hypotenuse. Tangent is always opposite over adjacent. All right, let's look and see how we could use these. Okay, it asks for what are the sine, cosine, and tangent ratios for angle T. Now you can do these trig ratios, this SOHCAHTOA thing, with any acute angle. We would never put our right angle here. It's always the acute angle. Okay, so the sine of T. So let me write up here so that we remember our acronym. It's SOHCAHTOA. All right, so when they ask us for the sine, that means I want to write the opposite over the hypotenuse. So I come over here to this triangle, and I'm talking about angle T. So right here, from angle T, I want opposite and hypotenuse. Well, opposite is always across the triangle, so the opposite leg compared to angle T is 8. The hypotenuse is always your longest leg across from the right angle, so that's 17. So this ratio, sine of T, would be 8 over 17. Okay, let's try cosine of T. From T, cosine is supposed to be adjacent over hypotenuse. So the adjacent leg is the one that it's right next to, but it's the leg. It's also next to the hypotenuse here, but that's not a leg. So we call this the adjacent leg. This is your hypotenuse. I'm going to write cosine as 15 over 17. Okay, the last ratio then is tangent, opposite over adjacent. So I'm looking from angle T. So I come here to angle T, opposite straight across. So that's 8 over the adjacent. That's the one that it's next to. So 8 over 15. So it's kind of like every which way of rearranging those legs. Those are those ratios. Now if I were to mix this up and change the angle and say maybe angle G here, well then when I'm looking at that, that would be different ratios because this is a different size angle, so those ratios would be different. Opposite would actually be over here, and this would be adjacent. Hypotenuse is always going to be that 17. Okay, now the whole point of using this SOHCAHTOA is to help us find missing parts on triangles. And I'm just going to work with one triangle. It's not like last chapter where you had to have 2 triangles and set up stuff. So it's just one triangle. It's got to be a right triangle, so we'll have a right angle in all of these. And then you have to know one of the angles. So you can see here that they've told me this acute angle is 39. So I'm going to base everything off of this lower angle down here. Here's my angle. Okay, so from that angle, that happens to be 39, I'm going to look and see which sides I'm dealing with. All right, so across from it is what I'm looking for. That's the opposite. Okay, so I know I'm going to be dealing with opposite. And then the 15 is the leg that's right next to it. That's the adjacent. It doesn't do anything with the hypotenuse up here. So I'm not looking for the trig ratio that uses hypotenuse. So one more time, I probably should have written this on the top of every slide, but you've got SOHCAHTOA. And I want to use the trig ratio that uses opposite and adjacent. So looking through my options, opposite and adjacent is this one. I'm going to be using tangent. So I'm going to write this out. The tangent of, now I don't have letters on this like I did on that last picture. I called it tangent of T. Okay, I don't have a letter, but what it is it's the 39. It's the tangent of 39 equals x over 15, opposite over adjacent. And now I'm going to solve for x. Since I'm dividing it by 15, I'm going to come back and multiply by 15 on both sides. And then I'm going to type that into my calculator. 15 times the tangent of 39. And then I will know what x equals. Now just as a quick side note, if you've got a fancy graphing calculator, you need to go to your mode and you need to check and make sure that you are in degree mode, not radian mode. If you just have a basic scientific calculator, it automatically defaults to degree mode, so you should be fine. So we're going to take 15 times the tangent of 39, and you just type that in your calculator just like that. 15 times, and it's that TAN button that you probably have never used, tangent of 39. Press enter, and I got x to equal 12 point, I'm just going to, up says round to the nearest tenth, so I'm going to go 12.1 for that leg. Okay, what do you think? It's something totally new for us, isn't it? Okay, let's practice again. Next one, I have to use the angle they give me, so it looks like they give me this bottom angle again. Okay, and again, it doesn't matter which acute angle they give you. You just grab one and then you're working with, okay, what are we working with? Let's see. We're looking for the opposite, so I'm going to want to use the trig ratio that has an opposite. And the 20 is that longest side across from the right angle. That's the hypotenuse. So then I come up here to the top and I look at SOHCAHTOA and look at which one uses opposite and hypotenuse. That would be sine, has the O and the H, opposite and hypotenuse. So I'm going to use sine. The sine of 35 will equal the opposite, which is x, over the hypotenuse, which is 20. Okay, so this is set up just like last time. I've got my x, I'm dividing it by 20, so I'm going to get it by itself by multiplying by 20. So in my calculator, I'm going to type 20 times sine 35. If you do it the other way, I should probably mention, if you hit sine 35 first, then you got to be sure you close that parenthesis because it automatically opens a parenthesis on your calculator right there. You would want to close it before you multiplied by 20. If you just do the 20 first, then you don't have to worry about it. All right, I have my x to end up equaling 11.5 on that one. Okay, one more time. I've got this angle that's a 41 here, and which sides are we using? Well, since your right angle is way up here this time, the 11 is actually your hypotenuse. Got that. And then the x is right next to your 41, so that's going to be your adjacent. Look up here at SOHCAHTOA, I have adjacent and hypotenuse, that's right here. I'm going to be doing cosine. I set up my formula. Cosine of 41 is equal to adjacent over hypotenuse. Multiply by 11 on both sides, and in my calculator, 11 times the cosine of 41, and I have x equals 8.3. So I tried one of each type there. All right, so looking at this one, they've given us both angles. Let me shrink this down a little bit so I have some more space to work. Okay. I want you to kind of try a couple things here just to emphasize that there is a wrong way to do this, but there is more than one right way. Let's start with this. Let's say we're going to use the 28. Because they gave us two angles here, so we have some options. They gave us the 28, so let's pretend we're going to work with the 28. Now I'm looking for x here. This is your longest side across from the right angle, so that's your hypotenuse. And then 50 is across from the 28, so that's going to be your opposite side. Do you know which trig ratio that is? I'm going to make you peek back this time instead of me writing it. So this opposite and hypotenuse, that should be sine. Okay, so I'm going to say the sine of 28 is equal to opposite, which is 50, over hypotenuse, which is x. All right, now this is actually a different problem than it was last time, so that's why we kind of wanted to go through this. There's a few things I want to touch on in this slide. The previous examples, we always had the number on the bottom. Okay, well, this time it's 50 divided by x instead of x divided by 50. That makes this a little bit trickier of a problem to solve because I'm dividing by x. So what I have to multiply this time is I have to multiply by x. You always multiply by what you're dividing by. So I'm going to multiply both sides by x. It just cancels out over here, so I just get my 50. And on this side I have x times the sine of 28. Now when I'm solving, I need to isolate the x. So I did that multiply by x just to get rid of the fraction. Now I'm going to have to go back and I'm going to have to divide by the sine of 28 on both sides. So to do this one in your calculator, instead of multiplying, you're going to be dividing. So I'm going to do 50 divided by the sine of 28. And I got x to end up equaling 106.5. All right, so let's go through why did we do that differently here. It's because your x was in your denominator. If you end up setting up your SOHCAHTOA and your x is in the bottom, then you have to multiply by the x and then you'll come back and divide. So it's like an extra step of work if you have your x on the bottom. Now, I want to try something else with you. I want you to look at a different scenario. What if instead of using the 28, what if we chose to use the 62? So I'm going to use the 62 this time. Now, when I'm working through this, this is still the hypotenuse. That doesn't change. But the 50 is now adjacent to my 62-degree angle. Well, that's a different trig ratio. Opposite and hypotenuse was sine. If I do adjacent and hypotenuse, that's cosine. And so I'm just running through this in case you chose to do it this way instead, and I'll show you. It might still work. Let's try it. So I'm going to use cosine of my angle, but I'm using the 62-degree angle, not the 28, equals, if you look back at SOHCAHTOA, cosine is adjacent over hypotenuse. Adjacent is 50, hypotenuse is x. And then this is that scenario where the x is in the denominator, so I'm going to multiply both sides times x. I have x times the cosine of 62 equals 50. Divide by the cosine of 62. X is equal to, let's try it, 50 divided by cosine 62. And what do you know? I still get 106.5. I get the same number. It doesn't matter which method you chose, it's going to get you the same answer because x represents the hypotenuse. And so it's not going to change, and both of these were valid methods. It's just whichever one you happen to choose. Okay, so now let's change this up a little bit. Let's look for an angle. Instead of always looking for a side, what if you already know the side and you're looking for an angle measurement? So in this one, okay, we're still going to use our calculator, but we're going to do the inverse operation. Just like you multiply to get rid of division or add to get rid of subtraction, those are inverse operations. We have an inverse sine or an inverse cosine that we can use to undo that operation. So let's take a look. What is the measure of angle x to the nearest degree? So I'm looking at angle x here, this one here. Which two sides do you think they've given me? Okay. I hope you're saying hypotenuse and opposite. Okay, opposite and hypotenuse. Now the question is that sine, is that cosine, or is that tangent? That's sine. So I'm going to say sine of, and previously I always knew the angle. I don't know the angle, so I just write x. The sine of x is supposed to equal the opposite over the hypotenuse. Do you notice here that your x is not within the fraction anymore? So I don't have to solve there. The x is over here. What I really need to get rid of is this sine, and I get rid of it by doing inverse sine. And we hit inverse sine by doing second sine in our calculator. So I'm going to type this just as second sine, and you can see there's like this little sine to the -1 thing. That means inverse. Second sine, 6 divided by 10. Right? And I get x to equal 36. Oh, it says to the nearest degree. That would actually round up then. To the nearest degree, I'm going to put in a 37. And x is your angle, so we'll put a little degree sign there. X is 37 degrees. Okay, let's practice that one more time. Again, they're asking for x, and this part B, here's your x. So you have to decide what they've given you. This is your longest side across from the right angle. This is your side that's right next to the angle, so that's the adjacent. And then I have to decide adjacent and hypotenuse. Is that sine, cosine, or is that tangent? That is cosine. Cosine of your angle, which is what we're looking for, cosine of x, equals adjacent over hypotenuse. Adjacent over hypotenuse. Okay. So to solve for x, I have to get rid of the cosine. To get rid of the cosine, I do second cosine. 15 divided by 20. Now 15/20 does reduce, but it doesn't really matter. You don't have to take the time to reduce it. Your calculator will take care of it for you. I got x to equal, to the nearest degree, I'd say 41 degrees. All right, so that anytime you're looking for the angle, that's what's important here. Anytime you're looking for the angle, that's when you do the second sign or the inverse button there. If you're looking for a side measurement, you don't do that. So some way to remember that that's the time you got to do second sign when you're looking for the angle. Okay, now here's what I enjoy about the SOHCAHTOA thing. It's like, why do you care? Well, why about finding those sides? Because triangles can be drawn in real life situations so often that's why there's a whole course about trigonometry, because it's very, very applicable. Let's try some. I have here a skateboarding ramp that is 12 inches high and rises at an angle of 17 degrees. How long is the base of the ramp? So if you're creating this ramp, or if a company is building a ramp, you gotta have to think about the dimensions and how this is going to play out. So here's my ramp, and it's not a very big angle. We don't want to get crazy here, but the angle measurement right here is 17 degrees. Now by drawing this like a ramp, I've created this right triangle, and it says that the skateboard ramp is 12 inches high. Well, that's going to be here at the end of the ramp. That's going to be 12. And then the question is, how long is the base of the ramp? So how much space on the driveway or in the road or wherever you're putting this, how much space do you need for that? This is your x right here. All right, so given this angle, let's see which sides we're dealing with. The 12 is across from the 17, so this is opposite. The x is right next to the 17, that's adjacent. Okay, I've got opposite and I've got adjacent. That would be sine, cosine, or tangent. Tangent. Okay, I am not looking for the angle. I already know the angle. So this is going to look like tangent of 17. You always put the angle right there with your sine, cosine, or tangent. That's where that angle fits. Tangent of your angle is equal to opposite over adjacent. So for me, that's 12 over x. Okay, looks like this is the one that I'm dividing by the x, so I have to take it times the x. X times the tangent of 17 would equal 12. Come back, divide by the tangent of 17 to solve for x. So in your calculator, 12 divided by tangent 17. I get x to equal, let's see what it, round to the nearest inch. I have a 39.2, so I'm going to go 39 inches. So that's how much space you'd have to have along the driveway or wherever. That's how big this ramp is going to be. Okay, let's try again. An escalator in the subway station has a vertical rise of 190 feet, 9.5 inches. Ooh, that's weird. Okay, and rises at an angle of 10.4 degrees. How long is the escalator round to the nearest foot? Okay, so here's my picture. My escalator is going up, 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 up. And then this is kind of this part here is the escalator. And that's the part that they say has a, oh wait, an escalator has a vertical rise. Ooh, vertical rise. This is your vertical right here. So that's how high that's going to get. So the question is, how long is the escalator going to have to be? How many steps are you going to have to put within that to get to this height? Okay, and I'm sure there's some sort of rule about how steep it can be. They're saying it's a 10.4 degree. So not everything is nice, pretty, perfect numbers. 10.4 degrees. The vertical, here's what's weird. I kind of dodged that, putting in the vertical rise right here. Since they want my answer in feet, I'm going to go ahead and leave this in feet. So it's 195 plus a little bit. Okay, what you have to do to get those inches turned into feet is you have to take that 9.5 and you have to divide it by 12 to see what part of a foot is that. So if I do 9.5, divide by 12, all right, I get 0.791666. Okay, so what this is then, that's the part of a foot that this is representing. So this is going to be 195.7, I'm just going to go 0.79. All right, so 190 feet and almost 196 high when it's all said and done. All right, let's see about our SOHCAHTOA now. Got this angle here. That's what I'm going to use. From that angle, I am looking. See, there's your right angle. So this is your hypotenuse. And then 195.79 is the opposite. All right, have we done enough? Do you know what that is? Sine. Okay, sine of your angle, that's 10.4, is equal to opposite 195.79 divided by your hypotenuse, x. Multiply both sides by x. Come back and divide by the sine of 10.4. So it looks like in my calculator, I'm going to need to type in 195.79, and I'm going to divide it by the sine of 10.4. All right, I was just looking at that because this seems crazy long, right? I have 1,084, and what do we round into? Round to the nearest foot. My 84 actually rounds up to an 85. That's measured in feet. That's a heck of a long escalator. I suppose it sort of makes sense because this is so tall, and this is an exaggerated, this is a 10 degree, that's really not that's not very steep at all. So it would have to be crazy long for it to ever reach this height because this is such a shallow, low angle. So I'm not sure the subway is going to have that much open space in there, but whatever. I guess I'm not building it. Okay, last two problems. All right, done with kind of the word problem things, but still going to be doing some SOHCAHTOA in here. Just merging triangles together so you can kind of see the right triangle that happens within there. All right, so this says find the values of W and then X, round lengths to the nearest tenth, and angle measurements to the nearest degree. Okay, got it. Let's start over here on the left. I'm going to do this triangle here with you. Let's start with this. Let's work on this angle here because I feel like that, or I mean this triangle, because I feel like they've given me most of my information in there. All right, I've got the angle. They've given me the hypotenuse. Sorry, I'm trying to use this highlighter and that's terrible. That's a hypotenuse. Okay, and then the W is opposite. Okay, so I've got, maybe what I just need to write is H and O, right? Is that enough? H and O, because that's what it's called in SOHCAHTOA. So H and O is sine. We're going to be doing the sine of your angle is equal to the opposite, which is W, over the hypotenuse, which is 6. Okay, solve for W by multiplying by 6. Multiply by 6. All right, I get 6 times this, or actually I'm just going to type that in my calculator. 6 times the sine of 30, and I get 3. It comes out nice. 3 is equal to W. Perfect. Okay, now I don't know if you noticed, but that's really a 30, 60, 90 triangle. Did you notice that? 30, 60, 90. This is your 30, this is your 90. That have to be 60 up there. The hypotenuse is 6, so the short leg is half that. Oh, looky there. Okay, good. I like it. It works both ways. Now let's try finding that other triangle. So I'm going to change it over. I'm going to look at this triangle now. And I just figured out W was 3, so I get to use that in this problem. This leg is 3. And I'm looking for angle X, and the two sides they give me are the 3 and the 4. The 3 is right next to it, that's adjacent. The 4 is the hypotenuse. So now this is adjacent and hypotenuse. What do you think? Cosine. cosine, and you're looking for your angle this time. So cosine of the angle equals the adjacent over the hypotenuse. So that's going to be a 3 over a 4. Now remember that when you're looking for the angle, that's when you hit your second button, your inverse cosine. And so you just type in second cosine, 3 divided by 4. And I have 41.4. Now they want them rounded to the nearest tenth, so I'll just, oh wait, this is the angle though. And the angle they want rounded to the nearest degree, that's going to be 41 degrees. So here are the two answers for that problem. Okay, now this next one I'm going to have you give a shot on your own. I've been doing them all with you. Let's see if you can try this one on your own. I'm going to help get you started so you're working on the proper triangles. Here's one of the triangles that you'll probably start with here. Do this blue one, which is this little right triangle. Now, SOHCAHTOA only works on right triangles, so don't be trying to use this triangle. This one here is not a right triangle. The second triangle that you're going to be dealing with, this is going to be fun. You're going to be actually finding, or this, let me change the colors on it and I'll tell you. You're going to do the blue triangle first, and then you're going to come back and do this pink triangle, the whole thing, because that's still a right triangle. Now, the problem with this is X is not part of the blue triangle, and it's really only a portion of the pink triangle there. Okay, but couldn't you, in the pink triangle, find this whole length? Whoa, what was that? You can find this whole length on the pink triangle, and then since you'll already have found W in the blue triangle, you can subtract those. So that's kind of tricky. Okay, is that tricky? Do I need to do this? I know you want me to do this with you. Okay, let's do it. Here we go, blue. I'm going to use my 56. The 10 is opposite. The W is adjacent. I'm not using that longest side. I'm not using this hypotenuse. So opposite and adjacent. Okay, that's an A there. Opposite and adjacent. Tangent. So tangent of 56 is equal to the opposite. Opposite appears to be 10. And adjacent is what I'm looking for, W. Okay, multiply both sides by W. This is the one that takes a little bit more work. W times the tangent of 56 equals 10. Come back and divide by the tangent of 56. And type that in your calculator to find W. I get 6.7. What are we rounded to? Nearest tenth. Okay, that's good. 6.7. All right, now I'm going to come back. I'm going to do it again. I'm going to look at my pink triangle. Now my pink triangle is the big triangle. So I'm going to be using this 34 that they gave me, 34 degrees. I know the 10 over here, that's opposite of my angle, so that's still an O. Okay, and then I'm going to be working on this whole side right here, which is adjacent to my 34. So again, the hypotenuse, which is this long leg over here, never gets used for anything. So I'm not using the H, I'm doing opposite and adjacent. This whole thing is going to be the adjacent. Opposite and adjacent, still tangent. This time of 34 equals 10 over. Now here's the problem. It's not X and it's not W. It's really W plus X. So I'm just going to call that whole thing Z for right now. Can I do that? I'm going to write it 10 over Z. Multiply by Z. Multiply by Z. Z times the tangent of 34 equals 10. Divide by the tangent of 34. Z is going to equal 10 divided by tangent 34. Oops, sorry, I did that one wrong. I hit times. 10 divided by tangent 34. And Z is 14.8. Now remember, Z is the whole leg. It's this whole thing. So if I want to find X, I'm going to take Z, subtract what I found earlier for W, and I'll be left with X. So X equals 14.8 minus 6.7. X equals, oh, I can probably do that in my head, 8.1. All right, there we go. That's a little bit trickier one. All right, that's all I have for you. Hopefully you get the hang of the SOHCAHTOA. Good luck.